So there's been an exciting development. I heard about it last night, about elements 114 and 116. The International Union of Chemistry, IUPAC, has decided that the evidence for the existence of these elements is now beyond reasonable doubt. So they are officially on the periodic table. All the super heavy elements are made by taking a heavy element, often one that is heavier than uranium. In this case, for 114, it's the element plutonium, which is 94, and then taking calcium, which is element 20, and accelerating the ion of calcium at a terrific speed and letting it bang into the target of plutonium once a month, once a week, very rarely. One of these millions or trillions of atoms fuses, so you get an atom of element 114. The problem is then to prove it. The work on elements 114 and 116 were part of an international collaboration between scientists in Russia in Dubna, which is to the north of Moscow, and American scientists in the Lawrence Livermore Lab in California. And they have come up with some data, and some years ago, 2004, so 7 years ago, they published papers about these elements. Brady, who likes forensic science and crime, says these you can imagine like witness reports. This is what the scientists saw, and they believe that this is really good evidence that they have made the elements. What has happened since then is that IUPAC has set up what they call a joint working party to examine the evidence, rather like a law court examines the evidence for a crime. And what has happened, the breaking news, is that this joint working party has published a paper. Here it is, and it's in the journal Pure and Applied Chemistry, which is the official journal of IUPAC. And what they have done is look at the evidence for all the elements from 113, that's the one beyond copernicium, right up to 118, the end of the periodic table, or at least the end of that row of the periodic table. And they've examined them all and have come to the conclusion that the evidence is really strong, as they put it, beyond reasonable doubt, for elements 114 and 116. So now we can include those with certainty in our periodic tables. In fact, my coffee cup seems to rather jump the gun, and already they've got 114 and 116 in colour with holes round it. I don't know who it was that designed this cup. The evidence that the working party looks at is quite complicated, and I, as a chemist, am a bit out of my depth here. But what they look at is the way that the scientists detect the decays of these atoms. When they create an atom, it bangs into a target and then sits in the target and begins to decay. And each time it decays, it goes from one element to another. Gamma rays, energetic waves, are given out, and these are detected. So you can see here the energy of the different gamma rays that have been detected. All sorts of decays have been discovered for elements from 113 up to 118, but so far the committee is really convinced by the evidence for 114 and 116.
What about the others?
It doesn't mean that they're wrong, it just means that there's still a bit of doubt, and people either need more time to think about it, or we need some more experiments before we can be absolutely certain.
So what's going to happen now to 114 and 116?
At the moment, these elements have the symbols UUQ and UUH, which are essentially the Latin for 114 and 116. And what will now happen is that these elements, all being well, will receive proper names. I presume that the teams whose evidence has been accepted will begin to think about names, though there may be some delay before the names come up. But what is certainly true is that because this is done by an international collaboration, that there will not be any nationalistic name, and it will be used to honour probably the name of one scientist. I still quite like Plancium as a name, but my views are not important here. So these decay chains are very specialist. You might expect that you just see them in a paper. If you've been watching carefully, you'll see that I've got a tie with them on it. And you can get a tie with these decay chains to celebrate the discovery of some of these elements.
Where'd that one come from?
This one came from Darmstadt, from the GSI, where elements 112, 110, 108 were made. And so, all being well, there's going to be a new tie for elements 114 and 116, and I hope I'll be given one of them too.